Okay, so classwork 5.1. Rational functions. First, we're going to start with, do you recall what a rational number is? Does this sound familiar to you? So if I can hear from you, like in chat or a nod, do you remember learning about what a rational number is? That it is an integer divided by another integer? Not in the slightest? Okay. Okay. Kinda. All right. So basically, we're going over it. So yeah. It's basically just something that you can write as a fraction, but you can't have a denominator that's 0. And so I think I've given you enough time to write down this definition, right? Have you all had enough time to write that down? Because then I'm going to get off the answers and we're going to look at these numbers. So based on that definition, which of these are rational numbers? Circle the ones that are rational. And if you feel like it, you can put an X through the ones that are not rational that you're sure of. And since I can only see like 5 of you, I have no idea if there's participation going on, if you're doing stuff. Thank you. Some of you are actually here. Okay, good. All right. So, are you doing this? Are you circling the numbers? Are you circling the numbers that you believe to be rational? I'm going to start with what looks most obvious. 2/3, does that look really, really obvious that that's rational? Do you realize that 3 and -5 are also rational? They can be written as 3 divided by 1 and -5 divided by 1. So all your really nice integer numbers are also rational numbers. And does everyone remember what an integer is? An integer means 0, 1, -1, 2, -2, 3, -3, 4, -4, so on and so on. So all of those integers are automatically rational because you can have each of them divided by 1. Can you see that 20/3 is rational? What about 14? Now, this might trick you, the next one. What about 2.7? Right now it doesn't look it, but let me go back to the definition. It's a number that can be written as a fraction of 2 integers. Not that necessarily is already written that way, but that can be written. So if you take 2.7 and you divide it by 1, so it's still 2.7, what can I do? What can I multiply the top and the bottom by and no longer be dealing with a decimal? So if I multiply by 10, that's going to move this decimal point over here, and I will have 27 divided by 10. So actually, it is a rational number. Any decimal number that ends is rational. In fact, any decimal with a pattern. Have you ever looked at what is 1 divided by 3? If you type 1 over 3 in your calculator, what does it tell you? It tells you 0. Oh, I see it. Yep. Now, this is a decimal. If you look at it in this form, it is a decimal number, and it does go forever, but it can be written as a fraction. So anytime you have a decimal number where it has a pattern, where it repeats, you guys have seen this type of symbol before, correct? So anytime it has a repeating pattern, it is possible to write it as a fraction. Now, what about the square root of 5? Do you feel like we finally found a loser in the rational number category? The square root of 5 is not rational. Square roots where it's not of a perfect square, they are always irrational. And we even call them irrational. Irrational. So rational and irrational are completely separate groups of numbers. Irrational are ones that cannot be written as a fraction. So square root of 2, square root of 5, square root of 3. Can you think of a really fun and tasty irrational number? What would be a delicious irrational number? Pi. Yes. Pi is an irrational number. Root 2. The most famous irrational numbers are pi and root 2. Now, for 2 to the third power, can you simplify that? Two to the third power is what number? It's the number 8. And 8 is an integer. That means that this is a rational number because it can be written as 8 divided by 1. What about 3 to the negative 3? What is that? If you write it with a positive exponent, what is it? Do you remember that the negative exponent says move to the other side of the fraction? And when it moves, its exponent becomes positive. You almost have it, except you accidentally said the negative there, and it's just kind of easy to do. So so that is the number 1 over 27. And 1 over 27 is a fraction with integers 1 and 27. This is also a rational number. What about log base 2 of 8? This takes us back a little bit. Is there a number who can be the exponent on 2 and you end up getting 8? You got it, 3. That means that this, even though it's in a logarithmic form, the number is still a rational number. But if I gave you log base 2 of 7, that would not be a rational number. It would fall under irrational. It would have a non-patterned decimal strain going on. Now, what about this last one? Rational? Yes or no? Good. Perfect. We cannot have divided by 0. Divided by 0, bad, bad. And so there you go. Now, I'm going to go back over to the answers for the next definition. The definition of a rational function is a function that can be written as a fraction of two polynomials, but just as before, the denominator polynomial cannot be 0. And just look at the similarity with the P over Q. And then you're going to move to the next, right underneath this. And without showing you the answers, circle the expressions that are rational. So see if you can figure that out. I'm going to leave this up for a moment because I know some people are probably writing it down still. Have you had enough time to write down the definition? Okay, I'm going to go back over. If you need me to leave this up, tell me in chat. Okay. For the very first one, do you think that this first one is a rational function? Is it a polynomial divided by a polynomial? Yes. Is the next one a rational function? Is it a polynomial divided by a polynomial? Do you remember that when I think it was the number 5 that was just when we first did polynomials, 5 was always that hanging out polynomial. A number by itself is still a polynomial. So this is a polynomial divided by a polynomial. What about the next one? The numerator has log x, which is an understood base 10 logarithm. Is a logarithm a polynomial? Nope. So this is not a rational function. What about the next one? Yes or no? Correct. Yes, it is a rational function, a polynomial over a polynomial. And the next one, the square root of x plus 3. I see some heads shaking. Correct. It is not. And one last one. Rational, yes or no? Correct. It is rational because, again, you can have a constant, a number, be a polynomial. What this actually means that all of our polynomials we were working with, they're all also rational functions. But our focus is going to be on the rational functions that are not polynomial. But we're going to have to do a lot with polynomials to understand these. Now, are you ready for the fun addition and subtraction? Woo! Let's start with, how do you do it with a pair of rational numbers? I want to point out to you that this problem right here, if you look at the denominator, do you see that the 7 and 3 have no common factors at all? And the only way to add those together is to literally multiply them by each other's denominator. So you're going to take that 2/3 and you're going to multiply its numerator and denominator by 7, so you don't change the value of that fraction. And then with 4/7, we are going to multiply its numerator and denominator by 3, so that I don't change what value it represents. But it's basically like taking two pizzas that are cut very differently and having to cut them into a lot more slices so that we can get to a point where the slices are actually the same size. Then we can talk about how much is going on. So in the denominator, we see that we have the 21 is now the common denominator. And do you remember how to add fractions? Keep that common denominator, because that's telling you how big those numerators actually are, and then add the numerators together, and that gives us 26. And I am not going to push the issue of writing rational numbers in, what's it called? Why can I not think of the word right now? Slipped my mind. Probably because it's Friday and I'm on the countdown. Yeah. Thank you. Thank you, Jason. To write this in mixed form, I'm not going to push that on you with the rational numbers. Right now it's considered improper, but how about we embrace improper and say, I take you, proper or improper? Good enough. And in the future, in your future math classes, you're really not going to concern yourself with writing it as its mixed number, where it's proper. Okay, now let's go over to the rational function. This time you have entire factors. You had a 3 and a 7 before. Now you have a big old x plus 1 and a big old x plus 3. You're basically just going to multiply each fraction by the other's denominator. So I'm going to take the 3 over x plus 1, and I'm putting a parenthesis around that x plus 1 to make sure that I don't mess certain things up. I'm allowed to multiply the top and the bottom by the same thing. And then I have the 4x over x plus 3, and I'm keeping a parenthesis around that x plus 3. I need to multiply its fraction by the other's denominator, which is x plus 1. Now, these two have a common denominator. And do you want to go ahead and just distribute the 3 over the parentheses? Do you want to distribute the multiplication over the addition? So if I distribute this multiplication, that's going to give me 3x plus 9. And then again, common denominator. And then I also need to distribute this 4x over the addition. Not quite. If you multiply them out in that box form, you'll see that it's got a a 4x in there, but you can write it as the expanded form. And so distributing the multiplication over the addition, I'm getting 4x times x is 4x squared, and 4x times 1. And just to repeat what I just said, if you want to multiply the x plus 3 and x plus 1 to get the quadratic, you can write it that way. I will make sure you're clear about when I expect you, if I expect you to expand it. So I've got my common denominator. I keep it, and I add the numerators. How do I add polynomials? Who gets to come together? With what I highlighted. So if you look at these two numerators that I highlighted, how can those terms add together? How do I add those two? I'm looking at adding those like terms. So with like terms, you're looking at this has an x, this does not have an x. Those cannot be added together. This has an x squared. It cannot be added with the 3x or the 9. This has a 4x, just like the 3x had an x. The 3x and the 4x can add together. So then, and by the way, if you are having Wi-Fi problems, you can contact the school and they have to supply you with Wi-Fi hotspots to help you out. That's the beauty of public school. So I'm going to write the polynomial in descending order. So the 4x squared has the highest degree exponent. And then next down are the x's. 3x plus 4x makes 7x. And then the lonesome 9. And that is good enough. If you feel, I am not going to expect you to write the numerator or the denominator in factored versus expanded form. Just get it to a point where it is a simplified form. Let me make sure I'm clear to you about what I'm saying. Both the numerator and the denominator are considered simplified. Simplified. It's just the denominator is simplified in factor form. The numerator is simplified in expanded form. They do not have to match. You do not have to have everybody in factored form or everybody in expanded form. There will be situations where you're going to want that. But as far as you saying I have a simplified rational expression, that is considered simplified. Yeah, you can multiply out the denominator. It's up to you how you want to write the answer. Just make sure that it is either simplified expanded or simplified factored for numerator and denominator, and they don't have to be the same type of form. Okay. Next. When I look at the rational numbers on the left, do you see that they have a common factor? With that common factor, let's rewrite the 8 is a 2 times 4. The 6 is a 2 times 3. And what I've done is I've broken the two of them down to see what factors they have in common, because while it may be unpleasant when you're dealing with the rational numbers, if you don't go for least common denominator, it is nasty if you're doing rational functions. You don't want the nasty version with the function side. So you want that least common denominator. Always first look to see if they have some things in common. Now I'm going to rewrite that. And when I look at fractions and the denominators, I think I can imagine like the fraction on the left looks over to the fraction on the right and says, what do they have that I don't have? I want it. And so that would be 3. So the fraction on the left needs to multiply by 3 over 3. And then the denominator on the right, the 2 times 3, looks over at the other one and says, what does that have that I do not already have? They have another times 4. I must have it. So we multiply by 4 over 4, and that's how we get our least common denominator. So 3 times 3 gives me 9. 3 times 2 times 4 gives me 24. 5 times 4 is 20. 2 times 3 times 4 is 24. And then we wrap it up by adding the numerators and keeping the denominator. And I'm going to leave the fraction as it is. It's improper, sure, but it is simplified. Simplified is the point where there aren't any integers that you can divide the top and the bottom by and make it a nicer pair of integers. Okay, now look at this one. Do you see factors that they share in the denominator? Yep, you got it. You do not want to multiply by an extra x plus 3 if you don't have to, because it's going to get really ugly really quick. So I'm going to rewrite these without the highlights. And now I look at the first denominator and I feel like it's looking over at the other one going, what do they have that I don't have? And they realize they have an x minus 1. Quick, quick, we need x minus 1. Then the fraction on the right side, its denominator looks over at the other one going, what do they have that we don't? Quick, hurry, they're trying to match us. And that would be the x plus 2. You really do not want to multiply those 3 factors in the denominator if you don't have to. So don't. If you find the least common denominator, there is no simplification you're going to have to worry about after you get through the next step. So now, if it's okay, I'm just going to write that big giant denominator once. And then the numerators are ready to add together. So I have a 2x times x minus 1, and I need to distribute the multiplication over that subtraction. So that's going to give me 2x squared minus 2x. And then the big plus sign. And the 4x needs to distribute over the addition that got brought in. So 4x times x gives me 4x squared. And then 4x times 2 gives me 8x. And now I need to add my like terms of the numerator. But the denominator is done. Unless you really feel like expanding that, leave it in factored form. And so let's see. I have an x squared and another x squared. So I'm going to add 2x squared plus 4x squared to give me 6x squared. Then I have a minus 2x and a plus 8x. Those can combine, and I have plus 6x. Now, this is fine to leave your answer just like this. The numerator is in expanded form. The denominator is in factored form. If you really feel like factoring it, you can. I'm not going to stop you, but you do not have to. Does that make sense? You do not have to go through the factoring. You are just bringing these two together in addition until you have, wait, what? Oh, sorry, I just got distracted by a blinking light and I realized it was my modem, but it was under a bat wing. So confused me. Anyway. Okay, now subtraction is basically the same thing as addition. Do you agree? So I'm going to actually skip 6a and just go over to 6b. And you can do 6a on your own. I've got the answers up. And I have no factors in common here. So the fraction on the left, its denominator looks over and says, they have an x minus 1. We don't have an x minus 1. Give me an x minus 1. And then the fraction on the right says, oh no, they took our thing. We've got to have their thing. Now we are just as good as they are. So they now have the common denominator. And I can distribute my multiplication over my subtraction. And that's going to give me 2x squared minus 2x. But this subtraction symbol I need to be extremely cautious with. And I'm going to put a parentheses right there. This 4 is going to have its multiplication distributed over the addition. That will give me 4 times x plus 4 times 3. But that subtraction sign has to go through as well. And you can either, there are different ways you can deal with it. I personally would go, how about I make this an addition with a negative 4 and then distribute the negative 4 through, and then I don't tend to screw up as badly. Or if I have a subtraction, I'll change it to add the opposites. So I've got that common denominator. And then I need to add like terms. The 2x squared has nothing to add with. I have some x terms. I have a negative 2x and a negative 4x, making a negative 6x. and then I have minus 12. While I could factor a 2 out and maybe factor some more, I don't need to. This is considered the end of the subtraction. So that's a reminder of addition, subtraction. Now we've got to remember multiplication and division. So let's start with rational numbers. How do I multiply rational numbers? Do you remember that you basically just multiply the numerators, multiply the denominators, and go yay? But do you also see that you can make your life easier before you hit this step? Because if I do just flat out multiply across the top, multiply across the bottom, I get 15 over 6 times 8, 48. But that fraction can reduce. Both numerator and denominator are divisible by 3. And that will leave me with divide by 3, I get 5. Divide by 3, yuck, 16. Would you have liked to stay away from the 48? Would you have appreciated not having the 48 in the first place? You can look at it this way, but be careful because you have to know what you can cancel. This multiplication sign, I remember when I was a kid, when I saw the multiplication sign, I literally just made it one big bar because I was like, well, that's just a waste of time. And then I could just look at these two and start canceling some things. So in my numerator, if I divide one of the factors by 3, and in the denominator, I divide one of the factors by 3, I have made my life simpler, and it's going to be easier to see 5 over 16. Less multiplication. But you can only cancel something that is a factor of the numerator with something that is a factor of the denominator. Okay, now exactly. So again, I personally like to just go, hey, it's really just one big happy multiplication family. Any factor in the numerator can cancel with any factor of the denominator. So I've got die, die. Perfect for Halloween. Now, nothing else cancels, does it? So that's as much as I can do. And now I just say, well, x plus 1 times x plus 5 in the numerator, and in the denominator, I can write that a little bit more simply by saying x plus 2 quantity squared. You do not have to expand your numerator or your denominator. With each polynomial, the numerator polynomial and the denominator polynomial, they just need to be written in either expanded simplified form or factored simplified form. Okay, checking the time. Do you remember how to do division? With division, you are going to multiply by the reciprocal. Do you remember that? And if you're wondering why can I do that, let's move down to this one. This is a big giant division bar. This is 3/4 divided by 2/9, just written differently. I want the denominator to be just a 1. To do that, I multiply by the reciprocal of the denominator, but I can't just multiply one side of the fraction. I have to multiply the other side of the fraction. This is why when you're dividing a fraction by another fraction, you multiply by the reciprocal of what's being divided. And then you go about your normal multiplication business and drop the over 1, and it becomes 27 over 8. So first thing we're going to do is rewrite it as multiplication by multiplying by the reciprocal, and then let the killing commence. The killing of only mathematical factors. We're killing algebra, not people or animals. Although I felt really bad killing a spider last night, but let's move on. All right, x plus 2's. Oh, oops, I pushed the erase button. That I did, but I killed more than I was supposed to. Die! There's nothing else I can kill, so I have to stop and call it a day. Now, do you see where this is going in the future, though? You are going to need to do your own factoring to see what cancels. But right now, it's given to you in factored form to just see that part of the process. And then lastly, this beast. It's not as bad of a beast as it looks. What? 9B. Did I? Oh, then, oh, you know what? The numbers are a little bit messed up and I never fixed them. I took out things that weren't useful and I didn't change the numbers. I didn't finish the cleanup process. So this may look scary. It'll look a lot less scary if you rewrite it as the numerator's fraction multiplied by the reciprocal of the denominator's fraction. And then it's a time to kill. Die! And do you see that there is something else? You have an x squared, which is x times x. And in the numerator, you have an x. So it's time to kill the x. Ah! And then see what's left. I have left a 3 and an x minus 1 in the numerator. In the denominator, I have left a 2 times x. And you can leave it in this format. You do not have to distribute the 3 through if you don't want to. So either factored or expanded for the numerator and denominator individually. Wow, I got through them all. I can't believe it. I did. I got through them all. So your homework. By the way, with your homework, here's what I recommend you do. I recommend that you do a little bit at a time. Do some one day, some another day. Between 1 and 2, Pick one of them to do tomorrow, one of them to do Sunday. These problems, you're going to go a further step. You're going to need to factor. So let's take a quick look at that. We factored when we did polynomials. Can you factor this polynomial? You can factor, in fact, you can factor out an entire 6x squared. And what's that going to leave? X plus 6. And from there, you can move forward with the, what do you call them? With finding the least common denominator. And you know what? We've got time, so I'm going to help you get started on your homework. All right. Can you factor these two? Oh, that question. Yes, you could divide the numerator and denominator by 3x and be done with them. So, okay. Y pen, Y. There we go. So divide by 3x, divide by 3x. And now you're almost done. So can you factor those two in number 4? Know that you're going to have to bring that step in. So what are their factors? Or should I leave that for homework? Good. If you have 3 fractions adding together, each has to have that same common denominator. And I realize some of these problems get difficult. You're going to want to factor that x squared minus 1 before you figure out who that least common denominator is. I'm going to give you another tip that's going to help you out a lot with your homework. Can you factor 4y squared minus 1? What you want to see is it's a difference of squares. So what can I square and get 4y squared? What expression do I need to square to get 4y squared? 2y. You got it. And then what number do I square to get 1? And then you have one of them is plus, one of them is minus. So you get a pair of conjugates every time you have that difference of squares. You'll notice it when you have 2 terms and a subtraction sign. Now, I want to point out something that's going to save you a lot of grief. These are almost the same. In fact, they're so close to being the same that I think you should make them be the same. Are you watching carefully? I can take this fraction on the left and I can multiply its numerator and denominator by -1. As long I can multiply a numerator and denominator by a same thing, and I do not change that particular fraction. So the fraction that is on the left there is negative 5y over, and if I distribute that negative sign through, do you see that that is the same thing as 2y minus 1? And now you're going to have a lot less time to worry about that problem. But I'll let you finish it. Oh, it's time to go. Do you want any more homework help? Oh, don't. You're not going to die. Okay. Good night. By the way, 13 and 14 are challenge problems, and those of you that are taking off didn't get a chance for me to warn you about them. I don't expect you to necessarily get them correct. They are very challenging challenge problems. Okay. I'm going to go into, what do you call it? Office hours. Oh, could I finish? And I just realized